Hi everyone! Welcome to my geometry lesson on translating shapes. Have you ever watched a cartoon character move across the screen? Like when they walk or run, but they don't change how they look at all. Today, we're going to learn how shapes do something similar. They move smoothly from one spot to another without changing size or shape. I'll take you through this step by step, showing you how to describe these moves using simple math and how you can translate shapes with confidence. So let's get started. In this video, we'll start by learning the important definitions about translations. Then we'll look at notation that shows how shapes move. And next, I'll walk you through some step-by-step examples. We'll finish with a practice problem and some take-home tips to remember. If you want, you can jump straight to the practice, but make sure you understand that a translation slides the shape without changing it, and a vector tells us how far and where to move it. Of course, you will need to know much more and how to read notation too. If that sounds confusing, don't worry. Just keep watching and it will all make sense. Before we can move shapes, we need to know where they are. And that's where the coordinate plane comes in, and this is called a coordinate plane. The coordinate plane looks like a grid made by two number lines crossing each other, so one number line here and one number line here. One goes left to right, the x-axis right here, and they all have a list of numbers in the x-axis, and the other goes up and down, the y-axis. Same way, they have a list of numbers, just like a number line. The first number tells you how far to move left or right, and the second tells you how far to move up or down. So here we have point C, and we say that point C is 4 units to the right and 4 units up. We can read this 4 on the x-axis, 4 on the y-axis. When they meet, point C, that's 4, 4. This grid helps us plot shapes and keep track of their positions. Understanding the coordinate plane is key to learning how to translate shapes. I apologize if the video or any contents of it is blurry. When we have a shape that we want to change or move, we use something called a transformation, and that's our second vocab word. A transformation is any way we can move, flip, rotate, or resize a shape on the coordinate plane. There are different types of transformations, like translations, rotations, reflections, and dilations, and each type moves the shape differently, but some keep the same size and shape. Transformations help us understand how shapes behave and move in math and the real world, and in this lesson we'll focus on one kind of transformation called a translation. In this image right here, we can see that the triangle is moving sideways left by 3. That's called a transformation. You're moving the shape and changing it in some shape or form. In this case, we're changing its position. As I mentioned before, this video is all about translating shapes. And a translation is a type of transformation where the shape slides from one spot to another without turning or flipping. So it's just changing the position, not the size or shape. Imagine sliding a sticker across the table. The sticker stays the same shape and size, but it moves to a new place. In a translation, every point of the shape moves the same distance in the same direction. That means the shape doesn't rotate, stretch, or change, it just shifts over. Translations help us move shapes easily on the coordinate plane while keeping them exactly the same. This kind of movement is called a rigid transformation because the shape stays rigid and unchanged. Later, you'll see how to describe exactly where and how far to slide a shape using vectors. In this image, we see that this rectangle, a shape, is being translated 3 units to the right. And this is the part where it's not translated yet, but eventually it will, and all of these points will move 3 units to the right. A vector is like an instruction for moving a shape. It tells us how far and in which direction to slide the shape on the coordinate plane. Vectors are written with 2 numbers inside angled brackets like 3, -2. The first number right here shows how many units to move left or right. Positive means right and negative means left. The second number shows how many units to move up or down. Positive means up, negative means down. By adding these numbers to every point of the shape, we slide the entire shape smoothly. So the first number relates to the x, and the second number relates to the y. And vectors help us describe translations in a simple and a clear way. Next, our final vocab is pre-image and image. This is fairly simple. The pre-image is the original image or shape before it moves. Think of it as the before picture of a shape on the coordinate plane. Every point in the pre-image has coordinates that tell us exactly where it is. When we perform a translation, we start with the pre-image and then move it according to the vector. It's important to show where the pre-image is so we can track the movement accurately. The pre-image helps us compare the shape before and after the translation. You'll often see the pre-image points written without any marks, like point A, right here. The image is the new shape after the translation. It's the after picture showing where the shape moved to on the coordinate plane. And each point of the image is found by adding the vector's numbers to the pre-image's points. To show a point is an image, we usually add a prime symbol, like A prime. So this little dash near the letter of a point is called A and then prime. We call that thing prime. The image looks exactly like the pre-image, same size, same shape, just in a new spot. And this is the case for rigid transformations. Comparing the pre-image and image helps us see how the translation shaped the shape's position. Now, understanding images lets us check that the translated shapes are correct. In this image, we can see that we moved the pre-image down. We don't know by how many, but we can see that we moved all those points down. We didn't change it to move left or right. And the size, of course, will stay the same. So this is the pre-image and this is the image. So let's go over some key notation. Our first thing is a vector, and as we stated before, this tells us how we move or translate our shape. Now, a vector is usually put into two kind of diamond side brackets. Now, this one and this one are those diamond side brackets. And our first number tells us how much we move on the x-axis, and our second number tells us how much we move on the y-axis. All you need to do are add these points to the corresponding x and y points of your pre-image. And if this doesn't make sense now, I promise you it will in our example problems. Our key notation number 2 is 4, -2. And I know this might seem simple, but I added this for the reason that this and this are not the same. So in the coordinate notation, we can see that there's parentheses. In the vector notation, it's kind of spiky little outward brackets. 4, -2, and we know how to read that as stated before. Now, a vector may not always be written with those pointy things. It can also be written in many other ways, but it should not confuse you. A vector can be written like T, capital, and the subscript can be 5, 3. You will read it exactly the same way. In some cases, the 5, 3 might be on the side of the T, but all mean the exact same thing, just in different notation. So here we have some example problems. Point A is at 2, 5. Translate it using the vector 3, -2. And what are the new coordinates of A prime? Now, I know this video is about translating shapes, but I thought we should start a little bit smaller. So these are how our pre-image or our graph will look like. It will have 2, 5. And now that our vector is 3, -2. So we're moving 3 to the right and 2 down. So our point will be possibly here. So all you need to do, as stated before, we have our point 2, 5. All you need to do is add the vector to it. So plus 3 equals 5, and 5 plus -2 equals 3. So our new translated point will be 5, 3. So 2 plus 3 is 5, and -2 plus 5 is 3. Our next example problem is actually a shape. So we're actually going to be doing an example problem on translating the shape. Triangle ABC has points A, 1, 1, B, 4, 1, and C, 2, 3. Now translate the triangle using the vector -2, 4. What are the new coordinates for A prime, B prime, and C prime? So in some cases, we don't need to plot it on the graph because this is pretty self-explanatory. You just add the corresponding points to the triangle or shape's points. So in this case, we'll be doing 1 plus -2, 1 plus 4. That's our point for A prime. For B prime, it's -2 plus 4, and 1 plus 4. Now you see that I'm adding the corresponding points, the x and the x, the y and the y. Don't get them confused, otherwise it will mess the whole process up. And you'll be like, I'm ending up with this totally different size. All you need to end up is a totally different position. So -2 plus 4 and 4 plus 1. Same way we'll be doing -2 plus 2 and 4 plus 3, and that will be for C prime. Here it's exemplified more, and this is how you will example write your steps. So a prime equals 1 plus negative 2 and 1 plus 4. Negative 1 comma 5. Notice how the points are always first and the vector is always written second. Next we have b prime, which is 4 plus negative 2 and 1 plus 4. And that point is 2 comma 5. Next we have c prime is 2 plus negative 2 and 3 plus 4. And that is 0 comma 7. Notice how the primes are really important. If we put a, then we'll be thinking, or the reader will be inferring, that you're referring to the pre-image. But no, that is not the case. We're referring to the translated point by the vector. So this shape will have the points a prime negative 1 comma 5, b prime 2 comma 5, and c prime 0 comma 7. If you want to plot this, I drew it out exactly for you. It is not necessarily needed, but this is how, for example, you would plot it. And the pre-image points are a little bit faded, but you can see them that a is right here, b is right here, c is right here. And it moved like so. So now we have a practice problem. I will do this with you, but I want you to pause the video and see if you can do it by yourself. You are given triangle ABC with these coordinates. A is 1, 2, B is 4, 2, and C is 2, 5. Now I want you to translate the entire triangle using the rule T, 2, negative 3. What are the coordinates of the new triangle A prime, B prime, C prime? Now I want you to pause the video to see if you can do this by yourself. Okay, now we'll be reviewing. Previously we had the points 1, 2 for A. Now we want to translate the entire triangle, so that means we need to translate each point or vertice, the key points. So we add the point to the vector. 2 plus 1 is 3, and negative 3 plus 2 is negative 1. Same way for B, which our new image point after adding these will be B prime, same A prime. So B prime will be 4 plus 2 and negative 3 plus 2. C prime will be 2 plus 2 and negative 3 plus 5. It is usually simple math, and it's just adding. You shouldn't have too big of numbers. So putting it in the correct form, we have A is 1, 2. So that means that A prime is 1 plus 2, 2 minus 3. B prime is 4, or B is 4, 2. B prime is 4 plus 2 and 2 minus 3. And B prime would be 6, negative 1. C is 2, 5, and C prime is 2 plus 2 and 5 minus 3. C prime is 4, 2. Now we have some take-home tips. What can you take home with you and apply it to your homework problems? So just remember that translations equal slides. There's no turning, flipping, or stretching. It's just a clean slide across the plane. And a translation vector tells you exactly how far to move: right, left, up, down. Think of it like GPS directions for your shape. And every point in the shape moves the same amount, so keep the order of your points consistent so you don't get mixed up. Like I stated before, we want to keep the vector in our process, our vectors on the right, and our points on the left. Positive numbers move you right or up, and negatives go left or down. It's like a math compass translating. You'll see the movement and avoid mistakes. Now you can either choose to remember this, or you can just simply add and choose to remember it that way. Now, when in doubt, sketch it out. It's pretty simple. Just plot it on the graph, and you'll see if your shape changes size or changes position. It's only supposed to change its position. Now, thank you for listening, and I hope you learned a lot.